Okay, so the next test here, test 3.2E, okay. Under exercise 3.2, question A12 of 4, textbook page. We'll find this on 51. Let's start then. Let me read the question. A1. The pair of equation x plus y minus 40 and x minus 2y plus 14 equal to 0 have unique solution to infinitely many solutions and exactly 2 solutions, no solutions. Which is the right choice? So let us solve and find it. So given to us here is the 2 equations, x plus y minus 40 equal to 0, let us say, question number 1. And here x minus 2y plus 14 is equal to 0. So they are already arranged in a pattern, so that's fine. X term in first place, y term in second place. The term having no x or y, which is C1 and C2, are both on the left side, so that's fine. So from equations 1 and 2, we see here, let us find out A1 by A2. Then the coefficients of x are called A1 and A2, so here in front is no number, plus 1. Here also 1, so 1 by 1 means 1, comma. Then B1 by B2 is equal to, B1 and B2 are the coefficients of y, so here in front of y no number means plus 1, in front of y is minus 2. So there's denominator minus means we always make sure we bring it up to the numerator. And immediately we see A1 by A2 is 1 and B1 by B2 is minus 1 by 2. They are definitely not equal. So if they are not equal, then we need not bother to find C1 by C2, because if A1 by A2 not equal to B1 by B2 like we see here, therefore the pair of equations, these two, have a unique solution, because when A1 by A2 is not equal to B1 by B2, we know they have a unique solution. So the right answer choice matching this one will be the number 1 there, which is unique solution. So that's how you find out. Okay, then next one, number 2, A2. The pair of equations x equal to 4 and y equal to 3 graphically represent lines which are coincident, parallel, intersecting at point 3, 4, intersecting at the point 4, 3. So we need to write the equation we have here very clearly. X equal to 4. Let's put this one as equation 1. Y equal to 3. Let us put this as equation 2. So on plotting, on plotting the graphs AB, on plotting, we'll just make it short, on plotting line AB and CD. Let's just draw the graph first. Then you can take your graph paper and then draw your x-axis and then y-axis. So here x0 x dash, y0 y dash, and value of x maximum is 4, so plus 1, 2, 3 and 4. Okay, then y maximum is 3, so on this positive plus, so 1, 2 and 3. That's enough, I think. So plotting here x equal to 4 is here, so the plotting will come out as a line here. So this will be the graph of the first equation 1. Let's mark it as AB. So this is the graph of the equation x equal to 4. So I can write here this graph here representing x equal to 4. Then the graph of y equal to 3, equation 2. Let's draw that. Y equal to 3 is here, so we draw a line right from there. And this is the graph of, let us say, CD, which is the graph of y equal to 3. So the two are intersecting here. Let's say P. Having value P, x value is written first, so 4, comma, and here P corresponding to y value is always y value written second. So they intersect at point P. So we can write here. So we can write here, since AB and CD, the two lines representing the graphs of equations 1 and 2 respectively, comma, they actually intersect. So you write intersect at the point P having x value equal to 4 and y value equal to 3. Therefore the right answer choice would be there, number 4. So which is saying the two lines graphs are intersecting. The choice is saying intersecting at the point, comma, 4, comma, 3, matching this one. That's your answer for A2. Okay, I hope you're getting it. So this is the graph of x equal to 4, equation 1, and this is the graph of y equal to 3, equation 2. So next, 2, 3, A3. If the pair of equations, first one here given to us, 8x plus 2y equal to 5k, denoting equation, let us say 1, and then 4x plus y is equal to 3, equation 2. It's fine because it's already arranged in a pattern. X term in first place, y terms in second place, term having no x and y, which is C1 and C2, are both on right side, so that's fine. So we have to find here if they represent coincident lines, then from equations 1 and 2, if you want you can write like that, since the, I'll go back to question, same language you can use, the pair of equations, these two represent, same language I'm using, represent coincident lines. Coincident lines means their graphs are coincident lines. Since they represent coincident lines, therefore the condition for coincident lines are A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Then only they represent coincident lines. So we're going to use that condition. Then that gives you A1 here, coefficients of x, 8 by 4, B1 by B2, 2 by 1, C1 and C2 are here, 5k by 3. Now they're saying find the value of k there. Okay, so we first, second, third part, we take this one because it contains the k part, and we take this one. If you want, you can cancel 4 1s are 4, 4 2s are 8. So here, first or second part you can take 2 by 1, and then take the third part. Why? Because the third part contains k. Only if you do that we can get the k value, isn't it? So 1 into 5k is 5k, cross multiplying. 2 3s are 6. So we're going to get here k is equal to, don't move the k, then 6 here. And then 5, no sign in between means into, shift right side, then come to denominator. So the right answer choice that match this k value is found in number 2, which is given as k value equal to 6 by 5. Hope you're getting right. The last question for this test part. A4. The point of intersection of the lines y equal to 3x. So here y equal to 3x, equation number 1, let us say. And then x is equal to 3y, equation number 2. So we have to find the point of intersection of these two, the lines of these two equations. So we can do that by solving by algebraic method also. So let's do substitution or elimination, maybe substitution. So from already arranged, so from equation 1 or 2 you can take 1, let us say. We have y is equal to 3x. Same thing, already arranged y on alone, so you can use that if you want. Equation 3. So putting equation 3 value, equation 3 value, substitution I'm doing, okay, value in equation. Since you got 3 from 1, don't put in 1, put it in 2. Then we're going to get x is equal to 3 into y is going to be replaced by this 3x. Y is equal to 3x. This y is replaced by this 3x. So to this 9x. So if you bring this 2 here, this one this side becomes minus 9x is equal to 0. Nothing left on right side. X minus 9x is minus 8x. Because minus 9 bigger absolute value, plus 1 smaller absolute value, because there's no sign means plus. So subtraction, 9 minus 1, 8, and bigger absolute value minus, so here minus, so minus 8x, that's why, is equal to 0. Then you can continue to do, okay, that implies here, x is equal to 0 divided by minus 8. If we shift this minus 8 into, then it will come to denominator. And we know that 0 divided by any number plus minus also is 0, no minus sign. So x is 0, we found out. So putting this x value equal to 0 in equation number 3, then we'll get y directly. So y will be equal to 3 into x. So 3 into x just now 0. So 3 zeros are 0. Therefore, our solution set is the required solution is x value 0, y value 0. That is, if you draw the graphs of these two equations will intersect this point that is called the solution. So therefore, the point of intersection of the lines, the point of intersection of the lines means the lines of the graph, the lines of this equation number 1 graph and 2 graph is at the point 0, 0. So that is how we can solve it. Okay, check how the textbook is done here. So that is the answer. So the answer choice that matches this 0, 0 is choice number 4. So you write down answer finally. Choice number 4 having 0, 0 as the point of intersection. That concludes the part for test 3.2E. Okay.